So I'm just going to. I was nearly not here because I closed my own computer on the plug, and it has destroyed the screen. So I've had to borrow this one, so it's not very clear. It's a very rubbish computer, but I hope it will work. Anyway, here we go. So for those people who are happy with all of this, just hang on, and we will get to proper questions in a minute. But I'm going to just show everybody else what I've done before is 3 triangles. This is a way to make it really simple in your head for calculating moles. Moles are funny things. I sometimes write something on a board which goes like this. For those of you who haven't seen this before, it may be helpful. I'm just going to change my camera to explain what moles do. So I'm just changing my camera. Okay, hopefully you can see me. Here I am. And if I have, I'm going to write an equation. I'm going to set fire to some magnesium. Magnesium burns in oxygen to form magnesium oxide. Can I see that? Yes. We would balance this. There's 2 oxygens here, so I need there. So 2 there, 2 here. You know that. Now, although oxygen goes around in molecules, magnesium doesn't. But the word molecule actually means the smallest particle that something exists as. So although magnesium oxide is ionic, so we shouldn't really talk about molecules, I'm going to use the word molecule for the smallest part of it just now. I'm now going to turn this into a sentence. And I'm going to say 2 molecules of Mg plus, you see there's only one, there's 2 Mgs, 1 O2, plus 1 molecule of O2 turns into 2 molecules of MgO. Now everybody knows that. That's simple. That's not Form 4 chemistry at all. But what I do this with my Form 3 students when I'm teaching them moles, and I just go, okay, you all know this, and they go yes, and I say, well, what are moles? And they go, oh, we can't do moles. And I say, yes, you can, because watch. All I've done is remove the fuel bit, and suddenly we have a sentence which goes 2 moles of Mg react with 1 mole of O2 to make 2 moles of MgO. So you say you don't know what it is, but I'm telling you that you do. There it is. It's just a number. Now that number, and I've sometimes said this, it's like a team of atoms or molecules. If I say to you a soccer team, you know it has 11 players. You do not need to say a soccer team of 11 players, because you go, I know it's got 11 players. If I turn up with 100, most of them are going to be sitting watching. If I have a rugby union team, it has 15 players on it. You don't say a rugby union team of 15 players, because if you turn up with 2, you will almost certainly lose. Okay, so this is just the word for a team of atoms or molecules. Only because they're really small, it takes a lot of them in one team, and a team is 6 times 10 to the 23, 600,000 million. You almost never have to think about that number, Avogadro's number. So this is the way that I teach my students here. I just say, okay, you know about molecules, you can turn this into a sentence, so you can do moles. So any equation becomes relatively simple. So I then say, all right, can you turn this like a little bit more complicated? This is burning methane to form water and carbon dioxide, and straight away they can go, ah, yes, 1 mole of methane reacts with 2 moles of oxygen to produce 1 mole of CO2 and 2 moles of water. Then I teach them how, because let's say this is a gas and that is a liquid when it's cooled down. I then teach them how to work out moles for gases, for liquids, for solids, for aqueous solutions, and so on. And that's what we're going to do now. So now I'm going to give you 3 simple triangles that allow you to work that out. So I'm going back to my computer. Coming back. Hello. Shocking. Okay, so now I'm going to share my screen. I'm going to give you a little presentation on the 3 triangles. And for those of you who don't know this already, it's probably working out writing down these bits and pieces. Sorry, I just got an email that came in and I started reading it, which is stupid. Right, here we go. So I'm going to go up to the beginning. Sorry, I was just adjusting it when I came in. Okay. So, hello. What's happening here? Ah, good. So I hope you can see a screen that says, Genesis, can you see one that says chemistry, moles 1 for students? Yes? Genesis, can you see that? Yes? Thumbs up? Cool. Excellent. Thank you very much. Okay, so here it goes. The first thing is to note that it is simply an amount of a chemical. Don't bother writing it down because you're not going to be asked what it is. It is just this very, very large number. It is an absolutely ridiculously large number. 600,000 million. That's 6.023 times 10 to the 23. Now, we tend to measure out solids in mass. So we tend to work out the measurement of a solid in its mass. So we would tend to, here I have a picture of somebody using a balance. They have a beaker and they're going to weigh something out into it, okay? And so we measure out the mass of a solid. Solutions, we normally have 2 amounts for them, 2 things that we measure. The volume, which is easy, lots of different ways of measuring volume, and concentration. Nothing to write down just yet. And for a gas, we would normally collect it and measure its volume. Okay, so we've got the mass, the mass of a solid, the volume and concentration of a solution, and the volume of a gas. And this is what I use. These are the triangles which I use, and I have silly ways of remembering them. Okay, the first one has grams at the top, moles down bottom left, and the RAM or the RMM down the bottom right. Now, if I want to work out the number of moles, I just cover the bit that I want. So I cover moles, and I know that moles equals grams over RAM or RMM. A for atom, M for more than one atom. Okay, so if I have H2, that's a molecule. If I have MNA, that is an atom. So this triangle is useful. Now, some time ago, I used to produce this triangle, and people said, I can't remember that. I can't remember triangles. I said, okay. And we came up with this idea. One of my students, many, many years ago, came up with this saying, which is moles RAM underground. And what it's saying is, here's moles, bottom left. There's RAM, and under G for ground. Well, it's not G for ground, it's G for mass, G for grams. But it helps you remember it. Imagine moles, when they make the holes underground, they push and they pull and they push. So they ram underground. And that is a silly way to remember it. But moles at the bottom, ram bottom right, grams at the top. Moles, ram underground. So that's the one for masses. So if you're given a mass of a solid, a liquid, or a gas, this is the one that you would use. The second one is for solutions. It's for solutions. And in the second one, come back. Moles is at the top. Moles is at the top. Concentration is bottom left. And the volume, which is, if it is in cubic centimeters, it has to be divided by 1,000. And I asked my students, I said, how can I remember that the moles are at the top on this one? Because most people can remember that it is concentration and volume, but they can't remember whether is it the concentration at the top, is it the volume, is it? And one of them said, well, do you remember the last triangle for the masses? And I said, yes, here it is. There we are, moles ram underground. So we were imagining the animals. And this student said, oh, well, this is about solutions. Yes. So this is about liquids. Yes. If I pour the solution on the ground, if the mole does not come up to the top, it would drown. I went, okay. So the moles in the solution one has to be at the top. Okay, moles at the top, concentration and volume at the bottom. Now, concentration is normally in moles per cubic decimeter or moles per liter. They are the same. 1 dm cubed is the same as 1 L, 1 liter. But the volume must be in cubic decimeters or liters. So if it is in cubic centimeters, you must divide it by 1,000. Okay, so first triangle, moles ram underground. That's for any masses. Second one, the moles have to come up to the top because the solution would make them drown. Concentration, volume at the bottom. The third triangle is for gases. And in gases, the moles go down to the bottom because they would fall through the gas. So they are down the bottom again. And the moles, the triangle is moles at the bottom, cubic centimeters at the top, and 24,000 or 22,400 underneath. You do not have to remember the number, like you do not have to remember the RAM or RMM, because they will always give you that in the question. This number here, they will give you 24,000 or 22,400. They will give you. It's important to know that there are two things that, about this. Firstly, if the volume is in cubic decimeters or liters, same thing, at the top, then the number at the bottom will be divided by 1,000. It will be 24 cubic decimeters. And the second thing is that the question will give you the molar volume, because sometimes in KCSE they use 24 and sometimes they use 22.4. 24 is the volume of a mole of gas at 298 Kelvin, that is 25 degrees Celsius. At 0 Celsius, it is 22.4. So they will give you that. You don't have to remember that. So I'm going to just stop sharing for a minute, and I'm just going to go through those triangles on my other board. It's just really quite important that we just get it, because in a moment, I'm going to give you some examples using these triangles. Okay. So 3 triangles, we call them masses, solutions, and gases. The masses, moles ram underground. The solutions, the moles would drown if they stay down the bottom, so the moles have to come up to the top. Here is concentration, here is volume divided by 1,000, okay? And gases, the moles would fall through the air, so moles are down the bottom again. This is their volume in cubic centimeters or cubic decimeters. This number here, you will be given 24,000 cubic centimeters. So you probably know all about these triangles, but if I want to work out the moles of a solution, I go, okay, moles equals concentration times volume. If I want to know the volume of a gas, the volume equals moles times 24,000. If I want to work out the RAM of something, the RAM equals grams over moles. So that's how I use them. I just cover up the one that I want to find, and it's really easy. In every question where they ask you a calculation, where they say how much of this would be produced, or how much of this, or something like an empirical formula, you are going to work out moles first. Because, like I said with the equation where I turned it into words, I need to know the moles of one side to work out the moles of the other side, okay? So they will always give you a part of one chemical, and they will ask you to work out the moles of that. Then you look at the equation to work out the moles of something else, and then you work out the quantity of it. Okay, I'm coming back to my presentation. All right, so we're now going to do a couple of examples. I'll just come back to this. Hello. I will now share my screen again. Okay, so here are some questions. I'd like you to have a go at these. They're very simple. Try A, B, or C, doesn't matter. A is how many moles are there in 4 grams of NaOH, sodium hydroxide? The second one, which is even easier in some ways, is 0.0055 grams of calcium carbonate and 1 kilogram of water. Just work out the moles of one of those, and we'll have a look at the answers in just a moment. So just to have a moment, I just want to make sure everybody can do that relatively simple sort of calculation. Okay, just have a go at one of those. Okay, I've got some answers. I've got something from Shama, absolutely correct. Good, excellent. That's the first one, well done. Second one, have a go at the second one. Silver Spring, was somebody showing me there? Absolutely, that's absolutely correct. Good, well done. Well done, Silver Spring. Osharika have some answers? Osharika have 2 answers, or maybe 3. Just down a little bit. Good, well done, Silver Spring, absolutely. Osharika, top one is fine. Yes. Second one. Yes. Up a bit, please. Yeah, the 0.1 is absolutely correct. Yep. Well done. Good. Excellent. Very good. Genesis. Let's see an answer. Kabiro. In this, the best thing you can do is when you have worked it out, if you can do the writing down, is to bring your paper to the front and show it to the camera. You can see what I'll show you what Glory student is doing at the moment here, like this. There we are. Absolutely right. Excellent. Well done. Yes. Up a little bit, please. Have you done the second one? Oh, yeah. Good. Don't shorten the significant figures. So don't get rid of the second 5 on that. But otherwise, that's very good. Well done. Excellent. So Kabiro, you need to do some writing down and some working out yourself. I'm now going to show you this so we can move on. So behind me, I have done the questions. Basically, all you need to know is to work out the RMM of each one of these. Here we go. So moles, and it's good in a question to write down your method to show that you know what to do. So you'd write moles equals grams over RAM or RMM. The first one is 4 over NaOH is 23 and 16 and 1, which is 40. 4 over 40, 0.1. Don't forget the units, write moles. The second one, 0.0055 grams over calcium carbonate has a nice unusual addition. Calcium is 40, 1 carbon is 12, 3 oxygens is 48. It's 100. So it's 0.0055 divided by 1,000, which will be 0.000055 or 5.5 times 10 to the minus 5 moles. Look at that. I say, put in your units and I forget. The last one, a kilogram, kilo is 1,000. A kilogram is 1,000 grams. So 1,000 grams over water is 18, 55.5 reoccurring, so 55.56 moles. Well done if you got those. That's really good. Very simple, important that you can do that. It's a really simple thing to do. It is always worth 1 mark, even if you don't go any further. Back to the others. Here we go. I'm coming back. It's not actually very far. It's just behind me. It's just that the camera takes a long time to wake up. So very good. Well done, students. Very good. So here we go. Here's those questions. Now let's have a look at some more. There are the answers. Here's the solutions. Okay. Here are some solution ones. In the first one, it says, how many moles are there in 25.0 cubic centimeters of 0.5 moles per cubic decimeter? So if you can remember the solutions triangle, moles was at the top, and it was moles equals concentration times volume in cubic decimeters, which means dividing the cubic centimeters by 1,000. Okay. In the second one, they are asking you to do something a bit more complicated. So the second one, B, is for those people who are finding this a bit too easy. So if you find A a bit too easy, B is for you, because it is saying 3.65 grams. I need to work out how many moles that is first. Okay, so I want to know what the concentration is. In the first one, it's just how many moles. In the second one, it is what the concentration is. Okay, so just have a moment having a look at those, see if you can do those. See if you can do at least the first one. I'll give you some minutes. Everybody needs to be doing some writing down, I hope. The headmaster Yestin has gone off and he's doing some other kind of writing down. Come on, Kabiro, let's see your action. Let's see you writing. Come on, Kabiro, great students. I know you're good students, but we need to really try to be active students. To really learn, you need to become active. You need to have a go at everything. So if you can have a go at it, Kabiro, that would be excellent. I am recording this, so you will be able to see it again later if you want to. I put all the videos, most of you will know, onto YouTube, so you can see them again later. So we'll see. Okay. So I'll give you a moment to have a go at those. And when you get an answer, just try to show me your working, please, so I can see what you've got. Many students working very well. Well done. So we have a student in Shama. Very good. Well done. Yes, that's very good. That's the first one. Well done. Excellent. Check if you in Shama, if you just share your answers with other people when they've had a go. If they're not, don't tell them the answer. Just let them have a go. Let's have a look. Usharika, please. Can I have a look, please? It'd be very good to have a look. 5.5 times. Sorry, I can't. Can you just move it across a little bit? You've got. Sorry, I missed that. I think it needs to go up a little bit. I think it needs to go up a little bit and a bit across. See if you can spot where the camera is. I'm sure you're right, but I just need to be able to see it. Have a go, Shama. Have a go at the second one if you can. Ah. Yes. Yeah. Very shaky hands, but absolutely correct. Thank you. Well done. Well done. Silver Spring, let me have a look. No. In this, with the second with the solutions one, Silver Spring, moles is at the top. So moles equals concentration times the volume divided by 1,000. Okay, so it's the concentration time multiplied by the volume. I'll show you it in just a minute. Sorry, Silver Spring, I missed that. My apologies. I'm going to go through it all in just a moment. I'm just going to show you it in just a moment. I'll just wipe off the old calculation. Okay, I'm gonna go through them. I'm just gonna go to the other camera. Does anybody else want to show me their answers first? No, we've got to be very careful. We've got to be very careful about this. In the first one, the question says, how many moles are there in 25 of 0.5 concentration? Okay, in 25 cubic centimeters of 0.5 concentration. So look at the board behind me and I will show you how to do this. It's very important. I know some people can do this, very well done, but I want to just make sure everybody can do it. The first thing is to know that this is the triangle. Okay, this is the triangle. I'll make it a little bit bigger. For solutions, moles is at the top, concentration is here, and volume is here. So if I'm asked to work out the number of moles, it is moles equals, just cover the one you want, moles equals concentration times volume. It's very important that you use the right triangle in the right way. Let me just put that up a little bit. Okay. So it says I have 25.0 cubic centimeters of 0.5 moles per cubic decimeter. So this is the concentration, okay? And this is the volume. So moles equals concentration times volume. Moles equals concentration times volume divided by 1000. Concentration, 0.5. Volume, 25 over 1000. That's how you do it. That is going to come out as 0.0125 moles. Okay? So just try really hard. When you have concentrations and volumes, you have to remember that the moles are at the top. So if you're finding the moles, I cover that, and it's the concentration times the volume, multiplied by the volume, not over the top. So with the masses, it's grams over RAM. With this one, it's concentration times the volume. Okay, it's really important. That's why we have the triangles. So you can try to remember what the triangle is saying. In the more complicated example, so this is the answer, I think. Yes. In the more complicated example, it says, oops, sorry. I need this in just a minute. I think it said 3.65 grams. Sorry. Shama, show me it. Brilliant. Well done. Very, very good. There's some students at Shama who can do this easily, so I need to move on. So I think it was 3.65 grams of HCl in 250 cubic centimeters. Grams do not fit in this triangle. Grams have to come from the first triangle. The first triangle is moles, RAM or RMM, grams here. So I work out the moles equals grams over RMM. So I say, okay, how many moles is that? So that is 3.65 grams over the RMM of HCl is 36.5. So that equals 0.1 moles. Now I have the moles here and the volume here. So I've got the moles and the volume. So I can find the concentration. I know this is a little complicated, but it is recorded, so you should be able to see it later. So I now go, okay, concentration equals, so I cover concentration, equals moles over volume over 1000. My moles I worked out was 0.1. My volume is 250, divided by 1000, 0.25. So it equals 0.4 moles per cubic decimeter, or a lot of people write it just as capital M. Okay, I hope that will make sense when you look at the recording if you want to. That was difficult calculation because it used two triangles. Okay, I'm going back to the other camera. Well done for those people who did that. That was really, really good. I'm very impressed. Okay, Genesis, wake up. Hey. Oh, yes. Good. All right, Glory. Are we still there, Glory? I know. This is chemistry. This is trying to get you so that at the beginning of December, you can do it because many people cannot do moles very well. Okay, here we go. I'm now going to share the screen again. Excuse me. Okay, here we are. The next bit, oops, I need to minimize something. So I did that. Okay. Okay. So now we have the volumes of gases one. And the important idea is, firstly, you just have to remember the triangle. Just like the very first one, moles at the bottom, the volume at the top, like the masses one, where we weigh out solids, sometimes liquids, sometimes gases, but mass at the top. For gases, it's easier to measure their volume, so the volume goes at the top. And at the bottom is the number you do not have to remember, because they will tell you it in the question, which is 24,000 or 24 cubic decimeters, or 22.4 cubic decimeters, which is 22,400 cubic centimeters. So now we're going to do a couple of questions just based on this. And there are some, the first one is really fairly straightforward. The third one is quite easy. The second one, B, is quite difficult. And D is the most difficult. So if you want to challenge yourself, I would ignore A and C. I would do B and D. In B, you have to work out how many cubic centimeters or how many cubic decimeters there are in a cubic meter. So a cubic meter will be 100 centimeters cubed. So 100 times 100 times 100, which is a million. Okay, 10 to the 6. In the second one, sorry, the fourth one, the last one, it's asking you for its molar mass. That's its RMM. That's a little bit different. That means changing around what you are doing with the triangle. So the idea is you should be able to do each one of those calculations using a different way, using the same triangle. Okay, just have a go. Have a few minutes looking at that. Come on, it's Genesis Joy. You're normally very good. Come on, stop eating your baro and start doing the calculation. Yeah, I know. Shama, just putting your head in your hands doesn't work. You have to actually concentrate. Oh dear. Kabira, you are very attentive students, and I like the way that you sit so politely, but it would be good if you can get more active. Glory, come on, Glory. You guys are normally really clever. Silver Spring, some people at the back there. Some people at the back there, just come on, wake up. Let's have a go. Let's get the calculator out. Let's have a go. Busharika, I'm not even going to talk to you guys. You are just so terrible, always. As soon as you have a question, as soon as you have an answer, just show me. If you're not sure about something, you could switch on your microphone and ask me. If you're not sure. You're doing well so far. If you're getting a bit of an idea on how to use these triangles, it's about being really knowledgeable about the triangle, okay, really knowing it. So I'm going to just put this one up behind me. Yeah, I know. That smells really nice. That's all right. I need to stop in the show and you can tell me. You need to change. Let's get the stuff that's on here. It would work. Yeah. There's the triangle behind me if you need it. So if I want the number of moles, I cover the moles here, and moles equals the volume in cubic centimeters over 24,000. If I want to work out the volume, I cover up, it's very difficult to work out what I'm doing here. I cover up the volume, and volume equals moles times 24,000. Okay, that's really good. So A and C are fairly easy. B is fairly easy, but using something slightly different. So let's have a look. Let's get some answers. Somebody tell me. Somebody show me what they've got, please. Ushirika up there first. You're showing me the end of your book, which is, I can't see. You're going to have to show the end of it, I mean, the flat of it to the camera. Kabiro, somebody has an idea. Let them come up to the front, please, teacher. Silver Spring. Somebody got the answer? Oh, Ushirika, move it across so I can see it. Work out where the camera is on the thing, please. I'm seeing tick, tick, B. For moles of, oh, B, you've done B, I say, well done. That's very good. And yes, sorry, yeah, you're right. That's very good. Silver Spring, can I have a look? I'll just pin so I can see. Oh, why isn't it pinning? I can't. Sorry, can you get a little bit closer, please? Oh, thank you. Oh, well done. Very good. Anybody else? Anybody else? Okay, I'm going to go through some of the answers. We'll see how they look. Okay. Okay, so I'm going to I'm just going to stop sharing just for a moment, and then I'll come to the answers. So here's the triangle. If I want the moles, it's always cubic centimeters over 24,000. If I want the volume, it's the moles times 24,000. You just have to, in your head, you just have to get right which way round you're going to use it. What am I being asked? Moles, volume, because eventually we can work all of it out. Okay. All right. So let's go back to this screen, and hopefully I will be able to show you the answers. Some people have already got the answers, which is brilliant. Let me just minimize that. Oh, sorry, I just missed somebody's answer. 0.1, well done. Yes, very good. Very good. Well done. Okay. So in the first one, how many moles of nitrogen are there in 2.4? So it's asking moles. So it's the volume over the molar volume, the volume for 1 mole. Okay. Now, 1 mole is 24,000 cubic centimeters, or 24 dm cubed. That's easy. So the first one is 2.4 over 24, which is 0.1. In the second one, how many moles of oxygen in 1 cubic meter? And somebody in Ushirika got this, which is really good. In 1 cubic meter, well, a meter is 100 cubic centimeters, sorry, 100 centimeters. So it is 100 times 100 times 100. So 1 cubic meter is 1,000,000 cubic centimeters, which is 1,000 cubic decimeters. So it would be 1,000 over 24, which is 41 2/3. 41.67. In part C, if I have 6 grams of hydrogen, what volume will it take up? Well, for that one, what I have to do is I have to use the very first triangle first. So I have to go, okay, 6 grams is how many moles? Because if I'm asked for a volume, I need one other quantity to tell me that. So I work out the moles. So I go, okay, 6 grams. Oh, yes, moles ram underground. So moles equals grams over RMM, 6 over 2, which equals 3. There it is. 6 over 2 is 3. So the volume is 3 times 24, which is 72. In the last one, it tells you 2.2 grams of X, not its real symbol, has a volume of 1.2 cubic decimeters. Well, this is more complex. This is much, much harder. What it's saying is I've got something with a volume of 1.2 cubic decimeters. It says it's a gas. So because it's a gas, I say, oh, I must use the gas triangle. So I can work out the moles of this gas. So moles equals the volume over the molar volume, 1.2 over 24. That will give me the moles. And then I'm going to use the first triangle. So here we go. So the first bit is I go 1.2 cubic decimeters is what moles? 1.2 over 24. That's 0.05 or 0.05 moles. From the question, 0.05 moles has a mass of 2.2 grams. Now, from the very first triangle, RMM is grams over moles, which is going to be 2.2 over 0.05, which is 44. What could it be? Well, it could be carbon dioxide. Okay, so let's try a proper examination question or two. This is a proper examination question. It was worth 4 marks. The first bit, I think, was worth 2 marks, then it was 1 mark and 1 mark. A student starts with 0.1 grams of Mg and adds it to 50 cubic centimeters of 1 mole per cubic decimeter, H2SO4, which is in excess. I'm going to show you how this works first. So Mg Okay, so here's the question on the board. So here is the question. I hope you can see that okay. In the equation, if I write the equation, normally in the question it will have the equation Mg plus H2SO4, simple, magnesium more reactive than hydrogen. It will replace the hydrogen. So we will get MgSO4 and the hydrogen will be displaced, kicked out. The H2 will be kicked out. Easy. I hope you can see that. Okay. Sorry. There we are. Okay. So magnesium, it told me that I have 0.1 grams. Now, if I have 0.1 grams, that is the first triangle. So automatically I then say, okay, first triangle. First triangle, moles, ram, underground. I try and remember that. I try and really simple, moles, ram, underground. So I've got 0.1 grams. I can therefore work out the moles. Okay, always in all of these calculations, work out the moles first. So here we go. I cover moles. I go moles equals grams over RAM. So moles equals 0.1 over the RAM of magnesium, which is 24. I haven't got a calculator. I can't do it at the moment. I'll come back to it. I can do it in my 0.04. In this one, I have a cubic centimeters and a molarity, a concentration. So this is the triangle for solutions. In the solutions, the moles are at the top, concentration is down here, volume is here over 1,000. Oh, I can work out the moles, great, because I have the volume, I have the concentration. So moles equals concentration times volume over 1,000. Moles equals concentration times volume over 1,000. Okay, back to my other one. So that tells me how I'm going to work it out. So I have just, using two of my triangles, I've worked out the 2 moles. Now that's really important. We'll come back to this in just a moment. Okay, back to the other camera. Okay, so there's what I've got so far. That is my calculation method. Let's share the screen. So for first bit was which is in excess, Mg or H2SO4? Okay, there's the equation. And there's the start, okay? And 0.1 grams of magnesium is 0.1 over 24, which is 0.00416. And the moles of H2SO4 is 1 times 50 over 1,000, which is 0.05. So which one is in excess? Oh, the H2SO4 is in excess. There is about 10 times as much, okay? So really straightforward. The acid is in excess. So in that reaction, all of the magnesium will be dissolved and we will get some hydrogen, we'll get magnesium sulfate, and we will have some excess acid. The second bit said, how many moles of H2 would be produced? Well, because we have more sulfuric than magnesium, the amount of hydrogen which is produced will depend on the magnesium, not on the H2SO4. There isn't enough magnesium to react with the H2SO4. And therefore, I go from the moles of magnesium, and because in the equation it is 1 magnesium makes 1 hydrogen, that's easy. Therefore, 0.00416 moles of magnesium will give exactly the same moles of hydrogen. Okay, exactly the same. So that bit comes from the equation. And this is the key bit. You work out the moles of whatever you need to start with, then you look at the equation. In the third bit, oh, good question. Why do we not use the moles of H2SO4? That is because there is too much H2SO4 to react with all the Mg, and therefore the amount of hydrogen will depend on the magnesium, not on the H2SO4. The H2SO4, quite a lot of it will not react at all. They are reacting, if you look at the equation, 1 to 1. So there is about 10 times as much, 11 times as much of the H2SO4 as there is of the magnesium. So most of the H2SO4 will not react. So what volume will the hydrogen be? Well, we've said that it is 0.00416 moles. 0.00416 times 24,000, which is 100 cubic centimeters. Okay, so that's how we do it. Okay. Now, I know that for some of you, this is like, many people find moles relatively difficult. I'll show that screen again for those people who are not very happy, who didn't write it all down. I'll show you in just a minute. I just want you to get this idea. If you can get the 3 triangles, if all you get from today's lesson, because in the next lesson, which is one of the last we have before the examinations, we are going to do examination questions. We are going to do a number of them, okay? We will do empirical formulas, molecular formulas. We will do volumes of gases, concentrations of solutions, and so on. But if today you can just remember the three triangles, and I mean remember them. So I need you to write them down, write them down, write them down, write them down, have a look at them, and just remember them. If you can remember them, you will be able to do moles calculations. I promise you. Now, you may have been taught a better way. You may have been taught a different way with your teacher. That is fine. It doesn't matter how you do it. But if you're not sure about it, if you didn't get it, if you didn't understand it when you did it, remember these three triangles, okay? I do not want to overwrite what your very good teachers have told you. So if you have a method that works and you can work out masses and moles, that sort of thing, don't listen to the three triangles. But if you didn't get it, if you did not understand it, remember the three triangles. Really important. Really, really important. Okay, so we're going to have a look at one more question. We've got another 10 minutes. That's enough time to do it. So I'm going to share another screen and we're going to see if we can do it. Here we go. Right. Here it is. Zinc metal and hydrochloric acid. It's a very similar question to the last one. Okay. Very similar, and they are both KCSE questions. They are both taken directly from examination questions, okay? And at first you may find these really scary, but they are not when you start to use your triangles or the method which you've been taught. Zinc metal and hydrochloric acid react according to the equation there. Zn reacts with 2 HCl. Remember what we said about turning it into words? 1 mole of zinc, 2 moles of HCl, 1 mole of ZnCl2, 1 mole of hydrogen. It tells you 1.96 grams of zinc react with 100 cubic centimeters of 0.2 mole hydrochloric acid. Which chemical is in excess? I'll tell you that zinc's RAM is 65.4. Oh, it tells you down at the bottom. I'd forgotten, sorry. So 1.96 grams of zinc, 100 cubic centimeters of 0.2 hydrochloric acid. Which one is in excess? Have a look at that. Okay, just have a look at that. See if you can work out which one is in excess. That's the first thing to do. Straightforward, nice and easy, I hope. Of course it's easy. You can do this. You can do chemistry. Of course you can. I'll give you just a few moments. You're making me hungry, Yestin. Have we got some answers yet, guys? Have we got some answers? Very good, Genesis. Can I have a look, please? Sorry, I was just writing down some stuff for myself. Let me have a look. Oh, why can't I pin? 0.01. And I think that's very good. Just look at the equation, because it's Zn plus 2 HCl, so we'll need twice as much HCl as zinc. That makes it a little bit tricky, because it's Zn plus 2 HCl. To be in excess, the zinc, there would have to be twice as many moles of the HCl. Okay. Okay, so that makes it a little bit more complicated. So you get the marks for writing down the moles, but then you have to go, I need twice as much. So I think both the two great students, one in Osharika and one in Genesis, who got that the HCl is in excess, you have a good point. Oops, sorry, say it again, Osharika. I'm really impressed by the people who got that. Oh, now you've changed your mind, Osharika. Okay, Osharika have changed their mind. It's okay. You're allowed to change your mind. I think I wouldn't know. Shama, let's have a look. Let's have a look what you've got, Shama, please. Or Glory, let's have a look. So I'll look at Shama first. Hold it still. 0.01. 0.02, close. HCl is in excess. Glory, HCl is in excess. Are you saying, Glory? Sorry, I can't see the bottom of yours, Glory. Show me the very bottom of it, please. Show it to the camera again, please. I'm going to stop sharing just for a minute. Whoops, sorry. Stop sharing. Okay. On the board behind me is how you work out the moles. I hope many of you have now got this right. So we are using two different triangles. The zinc one is the moles is grams over RAM. Hope you can see all that. Yep. So grams over RAM, 1.96 over 65.4, 0.03 effectively. Okay, 0.03. HCl, the moles, is concentration times volume over 1,000 because it's a solution. That's 0.2 times 100 over 1,000, which comes out as 0.02. So the moles of zinc is 0.03 and the moles of HCl is 0.02. So which one is in excess? Well, it looks like the zinc is in excess. No problem. The other thing is, though, that you have to remember is that for the HCl to be in excess, because it is Zn plus 2 HCl, we need twice as many moles of the HCl. So let's have a look. Let's have a look at the answer. I'm back on the other camera. So here we go. Come back on. Here we are. Okay. Here we are. So here's the. Whoops, sorry. Let me just get rid of that. So here's the solution. So we've got Zn and 2HCl. Using the first triangle, moles for zinc is 1.96 over 65.4, which is 0.03 approximately. The HCl is 100 over 1,000 times the 0.2, which is 0.02. So it looks like the zinc is in excess, and it is. To be in excess, if the zinc was 0.03, the HCl would have to be 0.06 or more, because it's twice as many. It's unusual for them to give you something like that. So that is 2 marks. That is the first 2 marks there, just there. So you get a mark for working out each one of these moles and then saying the zinc is in excess. That's really great. So looking back at the question, the next bit to do was to find the volume of the hydrogen gas. Now, because the amount, if you remember, the zinc is in excess, so we would have to work out everything based on the moles of HCl, because there is more zinc than there is HCl. So from the first bit, the HCl was 0.02. So if we look at the equation, HCl gives 2 HCl gives 1 H2. So 2 gives 1. So 0.02 will give 0.01. The volume, because they give you it at 22.4 in this one, 0.01 times 22.4, 0.224 cubic decimeters. Let's just look back on that one again. Here's the question. Sorry, here's the bit about it being in the zinc is in excess. That means that there will be zinc left over. So the amount of hydrogen produced depends on the amount of HCl. Because in the whole equation, we get 1 H2 from 2 HCl. We start with 0.02, so we'll get 0.01 moles of hydrogen. And if in the question at the beginning, it said here, right at the beginning, in B, it says 22.4 liters or 22.4 cubic decimeters, okay, at 0. So we're working with that, not 24. So here we are, whoops. So the volume is 0.01 times 22.4, 0.224 cubic decimeters or liters. 2 marks. That's 4 marks. That's a lot of marks on a question like this. Okay, so it's time to stop. It's time to finish. And I know for some of you that will have been really quite difficult. I know that. So I'm just going to stop the recording now.